Hi, good morning everyone. Okay, so yesterday we were discussing about solar system, right? In solar system, we have completed the discussion on sun, right? And we have started the discussion on planets, I think, right? Okay. So planets. So listen carefully. So planets we call non-luminous objects or non-luminous bodies. Why? What is the reason why we call non-luminous? Why not luminous? So luminous meaning those are having their own source of light, and those having their own source of heat, that we call luminous, right? So but here planets, they doesn't have their own source of light, and that's why we call non-luminous. And as of date, or as of 2024, May 2024, so we are having total 8 planets in our solar system. Earlier there were 9 planets, but now we are having only 8 planets. I will explain why, what is the reason, what happened, and why Pluto was removed from the planet category, right? So that we will discuss in this class, right? So your planets, the first important point to remember about planets is these are non-luminous. Just add one line, these are non-luminous objects. These are non-luminous objects because they doesn't emit light, because they doesn't emit light, right? They will not emit the light, and that's why we call non-luminous. So your planets are non-luminous objects, right? Non-luminous object, very important point, non-luminous objects. Non-luminous objects, right? So because they doesn't or does not emit light, that we call non-luminous. And here planets they gets or they receives light and energy from sun. Light and energy from sun, right? They receive light and energy from sun. Very important point. They receive light and energy from sun, and sun we call it is the only source of energy. Sun is the only source of energy in our solar system. The only source of energy in our solar system, it is the sun, right? Very important point. Sun is the only source of energy and even light also, energy and light. Only source of energy and light in our solar system. The only source of energy and light in our solar system, right? Next point. Listen. So here before 2000, just listen carefully. So before 2006, there were total 9 planets in our solar system. So there were 9 planets in our solar system before 2006. But what happened in the year 2006? So from 2006, listen carefully. In 2006, there was a meeting of International Astronomical Union, IAU we call. So International Astronomical Union, right? So this meeting was held, and in this meeting, so 3 criterias were fixed. Listen, 3 criterias. So 3 criterias were fixed for the planets, and out of 9, the planets those fulfills these 3 criterias will remain as a planet or will continue as a planet. If any one of the criteria or any one of the conditions are disqualified, then that will be declared as a dwarf planet. That was the condition fixed in the year 2006, right? And the 3 conditions or 3 criteria, listen. So 3 criteria are, first one is to call as a planet a celestial body. Listen, a celestial body should revolve around the sun. This is the first criteria to call as a planet. So here suppose this is the sun, right? Sun. So you have to call as a planet, the first criteria is a celestial body. A celestial body should circulate or it should revolve in the orbit. That is the first criteria. It should orbit or it should revolve in the orbit. Right? Very important point. It should revolve in the orbit. That is the first criteria. And second criteria, So to call as a planet, a celestial body should have sufficient mass and gravity. Sufficient mass and gravity. And mass and gravity for what purpose? To possess or to have, listen, to have a particular shape or structure, to have a particular shape or structure, right? Listen, so we are having the particular shape and structure because we are having the mass, right? And even the earth is attracting us towards its center. We are having gravity also. You take any object, it should have the mass. If it having the mass, it should have the gravity also, right? So you take any mass. Yesterday also we have discussed the mass will decide the gravity or gravitational force of attraction, right? So here the mass, like to call celestial body or to call as a planet, a celestial body should have sufficient mass and sufficient gravity. That is the second condition fixed by the IAU. And third condition, so orbit of one celestial body, should not intersect the orbit of another body, another celestial body, right? Just listen, suppose it is one orbit. I'll draw here. It is one orbit, right? And it is second orbit, right? And there are two objects, one object, and this is the second object. It's a second object. If their orbits are intersecting, suppose, so here this object is revolving in this direction or in this orbit, and this object is revolving in this particular orbit, right? And if their orbits intersects, means it should not intersect. There are three criteria. So your orbit should not intersect. They should not cross each other. They should not mix each other, right? So these are the three criteria to call as a planet. Listen. So to call as a planet, three criteria. First one is a celestial body should revolve around the sun. Second one, it should have sufficient mass and gravity to possess or to have a particular shape or structure. Third one is orbit of one celestial body should not intersect. This word is very, very important. Should not intersect the orbit of another celestial body. So there are three criteria. Among these three, just listen. In the first class, only we have yesterday class we have discussed the diagram of solar system, like Mercury, Venus, Earth, Mars, and its asteroid belt, Jupiter, Saturn, Uranus, Neptune, Kuiper belt, right? And we are having here, the Pluto, right? The orbit of the Neptune and orbit of the Pluto. Please remember, orbit of the Neptune and orbit of the Pluto are intersecting each other, and that's why Pluto was removed from the planet category, right? So because here among these three criteria, all the 8 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, they fulfill these three criteria. Only Pluto failed to fulfill the criteria. So Pluto fulfilled the first criteria because it orbiting around the sun. Today also it orbiting around the sun. Second condition also it is fulfilled. It also having the mass, right? So Pluto today also it having the mass. Today also it having the gravity. But the third condition was not qualified or not satisfied by the Pluto. And because of this third condition, so Pluto was declared as a dwarf planet, right? Dwarf meaning so incomplete or smaller one, you can say smaller one. So this planet could not fulfill the third criteria, and that's why it is declared as a dwarf planet. If you get the question, what is the reason or why Pluto was removed as a dwarf planet? It was removed as a dwarf planet because it could not fulfill the third criteria of IAU. So IAU, International Astronomical Union, the third criteria is orbit of one celestial body should not intersect the orbit of another celestial body, and the orbit of Pluto is intersecting the orbit of Neptune. So not the orbit of Neptune intersecting here. So both are intersecting, but orbit of Pluto is coming inside the Neptune orbit, and that's why here Pluto is declared, not the Neptune. Again the question also arises. So Neptune orbit also intersecting the Pluto orbit. The Neptune should be declared as a dwarf planet, but Here Neptune orbit is not going inside the orbit of the Pluto. The Pluto's orbit is coming inside the Neptune orbit, and that's why here Pluto is removed from the planet category and declared as a dwarf planet, right? And presently we are having there are 5 major dwarf planets in our solar system, and the trick to remember these 5 dwarf planets, the trick is CHEMP. So CHEMP is the trick to remember these 5 dwarf planets, and CHEMP meaning here, just listen. So here C meaning Cirrus, and H meaning Haumea, E meaning Eris, right? And M meaning make, and P meaning Pluto. These are the 5 major dwarf planets of our solar system, right? And among 5 dwarf planets, the largest dwarf planet is Pluto, right? It's very, very important point. Pluto is the largest dwarf planet of our solar system. We are having 5 major dwarf planets in our solar system, and 5 are the trick to remember 5 dwarf planets is CHEMP, right? CHEMP, CHEMP. C meaning here Cirrus, and H Haumea, and E meaning Eris, and M meaning make, and P meaning Pluto, right? It's very, very important point. Just add a few points. So have you taken this point? So planets are non-luminous objects because they doesn't emit light, right? And they get or receive light from light and energy from sun, and sun is the only source of light and energy, right? Next point. Before 2006, there were 9 planets in our solar system. Before 2006, there were 9 planets. Before 2006, there were 9 planets in our solar system. Before 2006, there were 9 planets in our solar system. There were 9 planets in our solar system. There were 9 planets in our solar system. But in the year 2006, IAU, International Astronomical Union, IAU had declared Pluto as a dwarf planet. 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 Pluto as a dwarf planet. Dwarf planet. Because it could not fulfill or satisfy. Because it could not fulfill or satisfy. Because it could not fulfill or satisfy the third condition or criteria. It could not fulfill the third condition or criteria of IAU. Third condition or criteria of IAU, International Astronomical Union, right? Full stop. Next point, put the heading criterias for planets. Criterias or conditions for planets. Criterias for planets. Criterias for planets. Criterias for planets. Write down. So here there are 3 criterias, and there are 3 criterias. They are, first one is a celestial body should revolve around the sun, and second one is a celestial body should revolve around the sun. And you can take this diagram. It's a celestial body. A celestial body should revolve around the sun. A celestial body should revolve around the sun. Take this diagram, right? That's the first point, very important point. A celestial body should revolve around the sun. So second point, a celestial body should have sufficient mass. A celestial body should have sufficient mass and gravity. A celestial body should have sufficient mass and gravity. A celestial body should have sufficient mass and gravity. A celestial body should have sufficient mass and gravity to possess or to have to possess or to have a particular shape or structure, to possess or to have a particular shape or structure, to possess or to have a particular shape or structure, particular shape or structure, particular shape or structure, right? Third one, an orbit of a celestial body should not intersect, an orbit of a celestial body should not intersect the orbit of another celestial body, an orbit of a celestial body, an orbit of a celestial body should not intersect the orbit of another celestial body, right? These are the three criterias, right? And here very important point is where Pluto failed to fulfill the third criteria, and that's why it is declared as a dwarf planet, right? Next point, there are 5 major dwarf planets. There are 5 major dwarf planets in our solar system. There are 5 major dwarf planets in our solar system. There are 5 major dwarf planets in our solar system. There are 5 major dwarf planets in our solar system, right? Full stop. And the trick to remember this 5 is chimp. And the one most important point, out of 5, 4 dwarf planets, they revolves in Kuiper belt. This 5 revolves in Kuiper belt, very important. And only Ceres, it revolves in the asteroid belt. Right? So here there are total remember, there are total 8 planets, but before this is the asteroid, just 1 minute, this is the asteroid belt, right? And this rotates in these are in the Kuiper belt, right? Kuiper belt, these 5 rotates in Kuiper belt, and only Ceres rotates in the or revolves in the revolves meaning the complete one circle revolves. So here Ceres revolves in the asteroid belt, and Haumea, so Eris and Make and Pluto, they revolves in the Kuiper belt, right? Very important point. So 4 revolves in the Kuiper belt and 1 revolves in the asteroid belt. You'll ask the question, which of the following is the major dwarf planet of asteroid belt? Then answer is Ceres. And which of the following are the major dwarf planets of Kuiper belt? Then answer is Hemp meaning here Haumea, Eris, Make and Pluto, right? And among these, so Pluto is the largest dwarf planet. Largest dwarf planet. And here Pluto having two major natural satellites. So one is Charan and second one is Hydra, right? Very important point. So it having two major natural satellites. So one is Charan and second one is Hydra. This question already asked in the exam. So which of the following is the largest natural satellite of Pluto? So answer is Charan. So Charan is the largest natural satellite of Pluto. And Pluto is the largest dwarf planet in our solar system, right? Pluto is the largest dwarf planet and Charan is the largest natural satellite of Pluto, right? And among 5, how many planets revolves in the Kuiper belt? Answer is 4. And how many dwarf planets revolves in the asteroid belt? Answer is 1. And which is that? Ceres, right? Okay, next point. Is over. Done? Okay, now put the heading. So we'll discuss about the remaining 8 planets. They are very important. Is over, right? Okay. Next one. Just write down the types of planets or classification of planets. Classification of planets. So here planets are classified into two categories, right? One is inner planets and outer planets. So you write down on the left side outer planets, inner planets, and on the right side outer planets, right? First inner planets and outer planets. The planets are classified into two categories. Inner planets and outer planets. Outer planets, inner planets and outer planets, right? And they are classified by asteroid belt. In between we are having the asteroid belt. This asteroid belt. Right, it's an asteroid belt, right? So asteroid belt, it divides the planet into two categories, inner planets and outer planets, right? So your first point, write down first point, below inner planets, it consists four planets. So there are four inner planets, right? It consists four planets, and they are Mercury, Venus, Earth, and Mars. That is point number one. So inner planets consist four planets, and outer planets also consist four planets. Outer planets consist four planets, and they are Jupiter, Saturn, Uranus, and Neptune. So there are four inner planets and four outer planets. That is point number one. First difference between inner planets and outer planets. So Mercury, Venus, Earth, Mars, and four outer planets: Jupiter, Saturn, Uranus, Neptune, right? And these four inner planets, listen, these four inner planets, among these four inner planets, so your Earth is the largest one. Just listen. So your Earth is the largest one, and among outer planets, so Jupiter is the largest one, right? That is point number two. Write down point number two. Under inner planets, Earth is the largest. Earth is the largest inner planet. Very important point. Earth is the largest inner planet. Right? Listen, as the Earth is the inner planet, so here these four inner planets, these are also known as terrestrial. First listen, terrestrial planets, right? So terrestrial planets. These four are known as terrestrial planets because terrestrial meaning here Earth-like planets, and we call Earth-like because Earth is the larger one. So here in the inner planets family, so we call Earth-like. We can't call or will not call as a Mercury-like or Venus-like or the Mars-like. We call the Earth-like because Earth is the larger one. And in this, just listen, among these five, we will not call like a Saturn-like or Uranus-like or Neptune-like. We call Jupiter-like meaning Jovian planet. Listen first. So Jovian planets. Outer planets we call Jovian planet. Jovian meaning Jupiter-like. So we call Jupiter-like. We will not call Saturn-like. So because here Jupiter is the larger one. And for example, in any village or any place, if you go first time as a stranger, and if you ask this building, who's this building, then what they will tell? They will tell the name of the person who is the head in that family, right? So here if suppose in this family, in this house, if there are 10 people are living, but if someone comes and asks who's this house, then they will tell the owner name, they will tell the head name, right? So they will not tell the small children name, ki this is the bachcha ka ghar hai. No, they will tell this person name, like Adani house, Ambani house, or this is, because they will tell the elder person name, or they will take, suppose if someone comes to our family, and if someone asks who's this house, then they will tell our father names, because father is the head of the family, right? So they will not tell our name, but they will tell the father's name. Yes, this is this person's name karke. And that's why in this family, in the outer planets family, the head is here Jupiter, and that's why we call Jupiter-like planets. In the inner planet family, the head is Earth, and that's why we call Earth-like planets or terrestrial planets. You got this point? Okay, write down point number, second point only, right? So here Earth is the largest inner planet. Therefore, inner planets are known as terrestrial planets. Therefore, inner planets are known as terrestrial planets. Terrestrial planets. Terrestrial planets. Meaning Earth-like planets. Meaning Earth-like planets. Meaning Earth-like planets. Meaning Earth-like planets. Right? Full stop. This side. So Jupiter is the largest outer planets. Jupiter is the largest outer planet. Jupiter is the largest outer planet. Jupiter is the largest outer planet. Therefore, outer planets are known as Jovian planets. Therefore, outer planets are known as Jovian planets. Jovian planets. Therefore, outer planets are known as Jovian planets, meaning Jupiter-like. Meaning Jupiter-like. Meaning Jupiter-like. Very important point. Meaning Jupiter-like. So outer planets are Jupiter-like and inner planets are Earth-like. Earth-like. Right. Next point. Point number 3. Listen. So the inner planets are made up of rocks and metals, and outer planets are made up of gases and ice. And that's why they are larger in size. Outer planets are larger in size. They appears very big because they are made up of gases and ice. And your inner planets are made up of rocks and metal. They are very heavier, and that's why their size is less. If you get the question, so which planets are larger, inner or outer? Answer is outer planets. Outer planets are larger, they are bigger in size because they are made up of gases and ice. And inner planets are made up of rocks and metals. Right on point number 3. So these planets are made up of, these meaning inner planets, these are made up of rocks and metals. So inner planets are made up of rocks and metals. Very important point. So rocks and metals. Inner planets are made up of rocks and metals. Rocks and metals. Rocks and metals. Therefore, they are more denser. Therefore, they are more denser. Therefore, they are more denser. So if you get the question, which are the more denser planets, then answer is inner planets. Why they are more denser? Because made up of rocks and metals. They are more denser planets. So this side, point number 3. Point number 3. So these are made up of gases and ice. These are made up of gases and ice. These are made up of gases and ice. Therefore, these are less denser. Therefore, these are less denser. Less denser. And if you get the question, which is the most densest planet in our solar system? The densest meaning which having maximum density. So which planet having maximum density here? So Jupiter. Density. Just what I mentioned, no, less denser. Outer planets are less denser and inner planets are more denser, because outer planets are less denser because they are made up of gases and ice. And gases and ice density will be less. What is the meaning of density? Mass divided by volume, right? So density. And here volume meaning will take 1 square kilometer, right? 1 cubic meter. In 1 cubic meter, the mass will be less, right? Gas mass will be less, and the rocks and metal mass will be more, and so density will be more for the inner planets and density will be less for the outer planets, and that's why we call less denser and more denser. And here please remember Earth having the maximum density in our entire solar system. Write down here, note under point number 3, note, write down note. Earth is most densest planet in our solar system. Earth is most densest planet in our solar system. Earth is most densest planet in our solar system. Most densest meaning which having maximum density. Most densest planet in our solar system. And its density is 5.51 gram per centimeter cube. Its density is 5.51 gram per centimeter cube. 5.51 gram per centimeter cube. Very important point. And it's put here double star. Very important point. The most densest planet. Many students will get confused, and many students will say Jupiter is having the maximum density. Jupiter doesn't have the maximum density. Jupiter might be larger one. It's the biggest planet in our solar system, but density is very less because made up of gases and ice. So if you get the question, which of the following is the biggest planet or largest planet in our solar system? Without doubt, answer is Jupiter. And which of the following is the most densest planet in our solar system? Earth. Answer will change, and answer is Earth, not the Jupiter. So this is the UPSC preparation. UPSC preparation meaning is not the rocket science. Just you have to understand the differences, basic differences. And the students, they will apply the same concept for everywhere. If they ask the question which is the largest planet, they will mark Jupiter. Which is the biggest planet? Jupiter. Which is the densest planet? Jupiter. Just by listing the term biggest, densest, they will mark Jupiter everywhere. But densest meaning Earth, largest meaning or biggest meaning Jupiter, right? Very important point. And this is the third point, third very important point. Now fourth point, write down, fourth difference, the fourth point under inner planets. Fourth point under inner planets. Listen, so among inner planets, which two planets are twin planets here? Venus and Earth. So they are twin planets. What is the meaning of twin? They appear almost same. So because of their similar size and shape, because of similar size and shape, they appear same, and that's why we call twin planets. Write down point number 4. Venus and Earth. Venus and Earth. Venus and Earth. Venus and Earth are the twin planets. Venus and Earth are the twin planets due to their similar size and shape. Due to their similar size and shape. Venus and Earth are twin planets due to their similar size and shape. Right? This question also asked many times, which of the following are the twin planets? Right? Listen, in the outer planets category, which are the twin planets? So here Uranus and Neptune. Uranus and Neptune are the twin planets. Right? Write on this here in that table. Fourth point. Uranus and Neptune. Uranus and Neptune are the twin planets. Uranus and Neptune are the twin planets. Uranus and Neptune are the twin planets. Very important point. So inner twin planets and outer twin planets. Uranus and Neptune are the outer twin planets. You can mention outer twin planets. Outer twin planets. And Venus and Earth are the inner twin planets. Inner twin planets and outer twin planets. Outer twin planets. So if you get the question, which of the following are twin planets? If you get a simple question, which are the following are inner twin planets? Just listen first. If there are 4 options, right? And this is the question, which of the following are twin planets? Twin planets. Which of the following are twin planets, right? And your first statement, Venus and Earth. Second one, Venus and Mars. Third one, Uranus and Neptune. And D1, Saturn and Neptune. What is the answer here? First one is Venus and Earth. Second, Venus and Mars. Third, Uranus and Neptune. And here Saturn and Neptune. What is the answer? A or B or C or D? A. How many of you are saying A? Please raise the hand. Those are saying A. A is the correct answer. A and C, but there is no A and C, no, only we have to select only one option. So if the statements are given 1 and 2, you might have you have selected 1 and 2 or 1 and 3, but here only we are having only 4 options, A, B, C, D, and you have to select only one option. And in the OMR sheet, if you mark both A and C, you will get 0 marks. In OMR sheet, you have to mark only one. Please remember, they will keep 4 bubbles, right, for A, B, C, and D. And if you fill both the bubble, your question will be rejected, right? And you will get 0 mark. Even though one might be correct answer among these two, but you will get 0 mark. Do you know this one? This rule of the UPSC and any state PCS exams. So you have to mark only one bubble. You have to circle only one bubble. If you circle 2 bubbles, the correct question also will become wrong. So that's why you have to circle here. Your answer here A and C. Listen carefully. Your answer A and C both are correct, but you have to select the most appropriate one. Among these two, the most appropriate. And the most appropriate is answer is Venus and Earth. So why most appropriate I will tell. Why the most appropriate I will tell. So here the mass of Venus is 82%. 82% of the mass of Earth. So mass of Earth is 5.97 into 10 to the power of 24 kg. And mass of Venus is 4.87 into 10 to the power of 24 kg. So here there is a because there is more similarity. So 82% is the matching, right? The mass of Venus is 82% the mass of the Earth. But when you compare this Uranus and Neptune, the mass of Neptune it is 70% of the mass of Uranus, right? So your mass of, listen, mass of Neptune is 70% of mass of Uranus. Its meaning, so there is more similarity, right? More similarity. They are very because within twin planets they are very close twin planets, and here only 70% the like no similarity, but here 82% the similarity. So you might be seeing that the twins. When the twins get birth, they both almost look same. Both almost look same, right? And almost you will find the 90 to 95% the similarity. Even the voice also same, right? And height also same, color also same, and most of the time the gender also same. But nowadays they are finding different genders also, but gender also will be the same almost. Height, skin, color, everything will be the same. That we call the twins, right? And here the similarity between the Venus and Mars is more, and that's why if you get two options, so here you have to reject option C and you have to reject, select the option A. And if suppose in the question, if the first option is Venus and Mercury, and here Venus and Mars is a Venus and Mercury, and in this case without doubt you have to mark the answer Uranus and Neptune, right? Because first statement is wrong here, then you have to select C. You have to select. You got the point? So that's why UPSC is not a rocket science. Just you have to understand like how to select the correct answer and how to write the mains answer. If you understand these two, so nobody will stop you from clearing this exam. So many students will fail in the exam because of this lack of clarity, right? So here most of the people will mark A and C both. Many people will mark, right? And they don't aware yet if they mark both. So here that question will become wrong, right? That question will be completely considered as a wrong question only, a wrong answer only, not question wrong, answer is wrong, question remains correct only. So here that answer will be considered as a wrong answer, right? And that's why you should not mark two question, you should not give two answers for a single question. You have to give single answer for a single question. You got this point? Okay. So here in this case, so here if you get the question twin planets, then answer is Venus and Earth. And if there is no option of Venus and Earth, then you have to select Uranus and Neptune, right? So here point number 4. So Venus and Earth Venus and Earth are the inner twin planets, and Uranus and Neptune are the outer twin planets. Now point number 5. Listen. So among these four inner planets, only one inner planet rotates in an opposite direction, and 3 planets rotates in the same direction. Which is that planet? Yes, very good. Venus. Only Venus rotates in opposite direction. Among outer planets also, only one planet rotates in an opposite direction, and remaining 3 planets rotates in the same direction. Which is that planet? Again, answer Uranus. Yes, very good. Uranus. So listen. So here point number 5. Listen carefully. So here Mercury, Venus, Earth, and Mars. When you compare these 3, right, the direction of Mercury is from west to east. Direction of Earth is also west to east. Direction of Mars is also west to east, right? West to east. But here direction of Venus is from east to west, right? So east to west, it rotates from east to west, and remaining 3 rotates from west to east. So the direction of Earth also west to east. Very important point. So Earth rotates from west to east. Mars also rotates from west to east. Mercury also rotates from west to east. Only Venus rotates from east to west. Why? What is the reason? Okay, listen. So till date we are having the evidence that Venus also rotating from west to east earlier, but some unknown celestial body collided the Venus, and that's why direction changed. For example, so this is the Earth, right? And Earth axis is inclined because this is the axis of the Earth, and Earth rotating west to east, right? Earth rotating from west to east. It's a west to east rotation. And Venus also, suppose if you consider this is a Venus, so Venus also rotating earlier west to east. But some object might have collided like this, and due to the collision due to the force exerted, its direction changed from east to west. So that is the evidence we are having till date. Otherwise, it was also rotating west to east in the earlier era or earlier days. But now after collision of some unknown celestial bodies, its direction changed from east to west. So that is the evidence we are having till date. Very important point. So its direction was west to east, but now its direction changed from east to west. And the same thing for the Uranus also. So Uranus also rotating from west to east earlier, but due to collision of some unknown object, so that is its direction changed from east to west, right? So write down point number 5, very important point, right? Venus is the only inner planet. Venus is the only inner planet. Venus is the only inner planet that rotates. Venus is the only inner planet that rotates from east to west. That rotates from east to west. That rotates from east to west. Venus is the only inner planet that rotates from east to west. Underline the word east to west, very important, east to west. And remaining three inner planets, and remaining three inner planets, and remaining three inner planets, remaining three inner planets rotates from, remaining three inner planets rotates from west to east. Remaining three inner planets rotates from west to east, west to east, west to east, west to east. Very important point, west to east. Remaining three inner planet rotates from west to east, west to east, right? So here Earth also rotates from west to east, but Venus rotates from east to west, right? Next point, point number 5. Point number 5, under outer planets, I don't. Only Uranus rotates from east to west. Only Uranus rotates from east to west. And remaining three outer planets, and remaining three outer planets, and remaining three outer planets rotates from west to east. And remaining three outer planets rotates from west to east, west to east. What east to west? West to east, right? Remaining three outer planet rotates from west to east, right? Very good, a very important point. Write down next point. Next point, listen. So here Uranus, listen carefully. Uranus rotates from west to east to west. Listen, Uranus rotates from east to west, but it appears like rotating north to south. Listen, don't write, just listen first. So it appears like rotating north to south, right? So it's rotating from east to west. Practically it's rotating from east to west, but when we see from the surface, Earth surface, or when we see from the some satellites or some aircrafts, so it looks like rotating north to south. So this question also asked many times. So many students will get confused whether we have to answer north to south or whether we have to answer east to west. If you get the question, what is the direction of rotation of Uranus? They will give the option. First option east to west, second option west to east, third option north to south, right? And or south to north. So when you get such questions, then option north to south also correct, right? North to south is correct, but it is not practical, or it is not in reality. In reality, it is east to west, but it appears like north to south because, just listen. So why it appears, I will tell. Suppose this is the Earth, just listen, this is Earth, and this is the equator, this one axis of the Earth, and this is the normal, right? And Earth axis is tilted by 23.5 degree, right? It is tilted by 20.5 degree. This is the axis of the Earth, and Earth rotating from west to east. Earth rotating from west to east around its axis, right? And if suppose this is the Uranus, and this is the normal, right? It is the normal, and its axis tilted by 98 degree, right? So here it is the 98 degree. It axis tilted by 98 degree, right? This is the axis of the Uranus. So this rotating from, listen carefully, it rotating from east to west, but looks like, listen, it rotates from east to west around its axis, but looks like rotating north to south, or appears like rotating north to south. Just I'll give you the example, just listen. So here Earth, and Earth axis tilted by 20.5 degree. This is the axis, right? This is the axis. So this axis tilted by 20.5 degree, and Earth rotating from west to east, right? And if you take it as a Uranus, listen. So this is the, if you take this is the Earth, and if you take Uranus, so this is the 90 degree, right? This is a 90 degree, and this is a 98 degree, right? So because this is the vertical, and this is the 90 degree, and this is 98 degree. So 98 degree, this rotating from east to west, but looks like north to south, right? It rotating from east to west only, right? See, this is east to west only. If you take the straight one, it rotating from east to west, and if you tilt it, this is the east to west rotating. If you make it looks like north to south, right? So here because of the tilting of the axis, it appears like north to south, but in practical, in reality, it rotating from east to west. So this is the concept, and many students will get confused because of lack of clarity in the books. So it is not clearly given in the books, right? It is not clearly given in the NCERT, and that's why students will get confused here. So practical, the actual rotation of the Uranus is east to west, but appears like north to south because of its tilting of the axis by 98 degree. At this point, just write down below the Uranus. Just write down below point number 5. Right, is point number 5. What I have written? So Uranus is the only outer planet that rotates from east to west, and remaining 3 outer planets rotates from west to east. Right, just write down below that point only, in the 5th point only. Uranus rotates from east to west. Uranus rotates from east to west. Uranus rotates from east to west, but appears like rotating north to south. But appears like rotating north to south. Due to inclination of its axis, by 98 degree. Very important point, underline the word 98 degree and put double star. Inclination of its axis by 98 degree. So its axis inclined by 98 degree, and Earth axis inclined by 23.5 degree. So Earth axis tilted by 23.5 degree, and Uranus axis tilted by 98 degree. Inclination or tilted, you can say, right? So its axis tilted by 98 degree, or its axis inclined by, or inclination is 98 degree. That's why it appears like north to south, right? Next point. Okay, listen. And one more important difference between the outer and inner planets. So here, listen carefully. Rotation and revolution. Just listen. Rotation and revolution. What is the main difference between rotation and revolution? Rotation meaning around its own axis, and revolution meaning with respect to some other object, right? If I rotate like this, so this one we call the rotation. Rotation meaning around its own axis, and if I travel around this camera, then we call the revolution. Revolution meaning with respect to some object, and rotation meaning around its own axis, For example, here, just listen. So here Earth is rotating around its own axis, right? It moving around its own axis, that we call the rotation. And if the Earth will travel, if you consider this as a sun, if the Earth will move surround to the sun, that we call the revolution. So revolution of the Earth meaning, so movement of the Earth around to the sun, that we call revolution of the Earth. Rotation of the Earth meaning around its own axis. Around its own axis we call the rotation. Rotation meaning around its own axis, or movement of any object around its own axis we call rotation. Revolution meaning movement of the object with respect to other objects, then we call revolution. And when the objects are rotating or revolving, just listen carefully, among inner and outer planets, which planets travels with, rotates with more speed? Which planets, inner or outer planets, rotates with more speed? Inner planets. Why? So inner planets are more denser, right? They are heavier, right? Made up of rocks and metals. Then how come they will rotate with faster speed? Outer planets, because they are made up of gas and ice, they are lighter in density, they are lighter in weight, right? They might be bigger one, but here their weight is very less, right? So if you compare the car and the truck, so which is heavier here? Truck is heavier. That's why it travels with lesser speed as compared to the car, right? And that's why I am telling here. So car is, it might be small, but it's less denser as compared to the truck, and that's why it travels with maximum speed, right? And please remember here, so outer planets, they might be bigger one, but they are made up of gases and ice, and that's why they travels with more speed. And inner planets, they are heavier because made up of rocks and ice, rocks and metals. As they are made up of rocks and metals, they are very heavy and they are having more density, and more dense material will travel slowly. As their speed of rotation is less, listen carefully. As the speed of rotation less, inner planet takes more time to complete one rotation. And here, for example, Earth alone takes 24 hours to complete one rotation. and Earth takes 365 days to complete one revolution. Listen carefully. So Earth takes 365 days if it is a normal year, and if it is a leap year, so Earth takes 366 days, and 2024 is the leap year. What is the meaning of leap year? One extra day will be added in that year, and the leap year will have 366 days. Why? What is the reason? Why the leap year will have 366 days? Okay, listen. So every year, listen carefully, every year Earth takes 365 days, 56 minutes, 48, just listen 1 minute. So 365 days, and here 23, listen carefully, 1 minute. So 365 days, right? 365 days and 5 hours, 48 minutes and 46 seconds, right? So your Earth takes 365 days, 5 hours, 48 minutes, 46 seconds every year, right? So for example, just listen, year in 2020, it takes 365 days, 5 hours, 48 minutes, 46 seconds. In 2021, in 2022, 1 minute. So here 2021, 2022, 2023 and 2024, right? So 2024 we call the leap year because one day will be added. Listen, 365 days, 5 hours, 48 minutes, 46 seconds. Every year 5 hours will be added. After 4 years, so 4 into 5, so 20 hours will be added, right? Again 48 into 4, almost 50, almost 3 hours, and almost 56 seconds, 56 minutes will be added, and almost here 4, if you take the here 4 minute, that 4 minute will be added to 56 minute, it becomes 1 hour. If you add 1 hour here, so it is 4 hour. If you add this 4 hour here, it is 24 hour. So here after 4 years, to complete 24 hours will be added. 24 hours nothing but 1 day, right? So 1 day will be added. And if you add 1 day to the normal 365 days, so it will be 366 days. And that 360 days comes once in 4 years, and that's why we call leap year. Leap year meaning after every 4 years 1 day will be added, because every year the additional time is 5 hours and 48 minutes 46 seconds. That will not count every year, but after 4 years we have to add all together, then 1 day will be added. That we call the leap year concept, right? So leap year concept, leap year meaning the year which having one additional day to the additional day than the normal year. Normal year consists 365 days. 1 day will be added after every 4 year, and that we call the leap year. And we call the leap year generally, so which is completely divided by 4, that we call the leap year. And 2024 is completely divided by the 4, that's why it is the leap year. 2020 was also the leap year. 2024, next 2028 is the leap year, right? 2032 leap year, 2036 leap year. You got the point? So leap year. And the people those are having birthday on 29th Feb, they have to celebrate their birthday once in 4 years. So because please remember in the normal year, so February month consists only 28 days, right? So your normal year, February comes only 28 days. And in a leap year, February month consists 29 days. So like February will consist 29 days only in the leap year, and the people those will get birth on 29th of Feb, they have to celebrate birthday once in 4 years. They have to wait for 3 years. But those are getting birth in other dates other than 25th, they can celebrate every year. But the people those will get birth on 29th of Feb, so they are very bad luck people. So they have to celebrate their birthday only once in 4 years, only in the leap year. You got this point? So here, because 1 day will be added to the February month during the leap year, and this year the people will celebrate their birthdays. Those are waiting from last 3 years, right? Okay, please remember. So here leap year will be added, right? And please remember, Earth takes 24 hours to complete one rotation, 365 days to complete one revolution. But Jupiter, listen carefully, but Jupiter takes just 10 hours, just 10 hours to complete one rotation. So Jupiter takes just 10 hours to complete one rotation. So when Earth completes one rotation, by that time Jupiter will complete two rotation and it will be in the third rotation. So because Jupiter might be bigger one, but it is very like lightweight, and that's why it travels faster, and it completes one rotation. It completes one rotation. If you take this is the Jupiter, it completes one rotation in just 10 hours. But Earth takes 24 hours to complete one complete rotation. You got this point? So Jupiter takes lesser time. Not only Jupiter, all the outer planets. Jupiter takes 10 hours, Saturn takes 11 hours, and Uranus takes 17 hours, and Neptune takes only 16 hours, right? Saturn, Uranus, Neptune. So these four planets takes lesser than the Earth. So Earth takes 24 hours time to complete one rotation. But these planets, outer planet takes time lesser than the inner planet. That is very, very important concept, and many students will get confused here only. They are very basic topic, very simple topic I am teaching here, very basic topic I am teaching here, but the students will get confused. And UPSC knows very well the students will get confused here only, and they will ask the question from such topics. If you see the question paper last 4-5 years, you will find the question from such topics, right? So please remember, outer planets might be bigger, they might be larger one, but they are less denser. Why they are less denser? Made up of ice and gases. As they are less denser, their rotational speed is more. As their rotational speed is more, they complete one rotation in lesser time as compared to inner planets. And in inner planet, Earth takes 24 hours to complete one rotation. But Mercury takes, listen carefully, Mercury takes almost 59 days to complete one rotation. So here Mercury takes 59 days. And almost in 59 days, Earth makes 59 rotations, but Mercury will make only one rotation. And in that 59 days, so Jupiter almost makes more than 500 rotations, right? Because it takes only 10 hours to complete one rotation. You got the differences? Just write down point number 6. Write down. Inner planets, write down below inner planets. Inner planets are more denser. Inner planets are more denser. Therefore they are having lesser rotational speed. Full stop. They takes here only the inner planets only. They takes more time to complete one rotation. Then outer planets, right? Full stop. Example, Earth takes 24 hours to complete one rotation, and your Mercury, 1 minute. Second, Mars takes almost 24.7 hours, means 24 hours, almost 37 minutes to complete one rotation. Mars and Earth are having almost same rotational speed. So 24 hours and 37 minutes. And then Mercury takes 59 days to complete one rotation. But Venus takes 243 days to complete one rotation. By 243 days, Earth makes 243 rotations, right? But Venus will make only one rotation in 243 days. So that this side are done under outer planets. As these are made up of gas and ice, they rotate faster. As they are made up of gas and ice, they rotates faster. Therefore takes lesser time Therefore, it takes lesser time to complete one rotation. Therefore, it takes lesser time to complete one rotation. To complete one rotation. Right. So here Vinay Kumar asking for everything why it is very simple, right? So but try to understand why they have taken February, meaning they have to for like no to explain something, or we have to take some base, right? We have to take some demarcation, we have to take some base, right? For example, you might be knowing in the economic class, like in economics, like no, we'll take the base year in the economics. Now 2011 we have taken the base year, because to measure something we have to take some base, right? So here 2011 we have taken the base year in the economics. So similarly, so 1 month will be taken as the base, right, for easy curve, because here February is taken, and if they take March, again you will ask why March is taken, because some base will be taken for just for easy understanding, right, or for easy remembrance. So here February will be taken as a base for easy understanding. If every year, if you take different months, it will be more confusing to the people. That's why they taken one reference, right? One reference will be taken, right? So for example, here in India also, so the northernmost point will take as a, which point will take northernmost point? Indira Cole will take the northernmost point. It's a reference line which indicates that is the northernmost point of India. It's a reference line. So if you mark that reference line, then only it's very easy to understand the people. This is the northernmost point of India and southernmost point of India is Indira point. Like it is very easy to understand that points will be marked for easy understanding. Indira point, it is in southernmost, and Indira Cole, it is in the northernmost. You should not get confused in the Indira Cole and Indira point. Again, the students will get confused. Indira Cole, Indira point, both are different. Indira Cole, northernmost point, Indira point, southernmost point, and Indira point located in the Great Nicobar. Right? You got this, Vinay Kumar? Okay. Next, Indian polity classes, make it available. Sorry. Hello, sir. Why you hided those Indian polity classes? Please make it available. Okay. So I'll speak to Ma'am Ji, right? Because Usha Ma'am Ji knowing this one. Sir, how many times sun is larger than the Jupiter? क्या क्या पूछते रहते हैं, कहो कितना बड़ा है, कितना छोटा है. Sir, what is the denser planet in our planet? What is the denser planet in our planet? In outer planets. So here Earth is the densest planet in the inner planets category, right? And definitely Jupiter is the denser planet in the outer planets. And the least denser it is the Saturn. Saturn is the least denser in the outer planet category, right? Okay. So listen, so your outer planets are made up of gas and ice, and that's why they rotate faster and they takes lesser time to complete one rotation. Out in this point, they take lesser time to complete one rotation. Example. So your Jupiter takes 10 hours. Then Saturn, it takes 11 hours. And then Uranus, it takes 17 hours. And Neptune, so it takes 16 hours. So as Uranus rotates in an opposite direction, it takes more time, right? Yet Uranus rotates in an opposite direction, that's why it takes more time. And here also Venus rotates in opposite direction, that's why it takes more time. Very important point. So Venus takes more time because rotates in opposite direction, and Uranus also rotates in opposite direction, that's why it takes more time, right? It is very important. Last one point in differences. Listen. So when you compare the revolution time period, so which planet takes more time? Which planets takes more time to complete one revolution? Inner planets or outer planets? Which planet takes to complete one revolution? One revolution meaning one complete circle around the sun. Yes, which planet takes more time to complete one revolution? Outer planets, because they are very far from the sun. Just listen. If you take it is a sun, so Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So here among these planets, so Mercury will take the lesser time to complete one revolution because it's very close to the sun. Then Venus, then Earth, and the maximum time taken by Neptune. Neptune takes maximum time to complete one revolution. So because it revolves around the sun and it is very far from the sun. So Neptune is very far. Listen. So to complete one revolution, it takes more time. It takes 165 years to complete just one revolution. And Earth completes one revolution in 1 year. That 365 days we call 1 year, right? Just listen here first, listen carefully. So here please remember, Mercury takes 88 days to complete one revolution, and Venus takes 225 days to complete one revolution, and Earth takes 365 days to complete one revolution. Mars takes 687 days to complete one revolution. Jupiter takes 11.9 years to complete one revolution, and Saturn takes 29.5 years to complete one revolution. Uranus takes 84 years to complete one revolution. Neptune takes 165 years to complete one revolution. You got this point? So here, which planet takes least time to complete one revolution? Mercury, because it is very close to the Sun. And which planet takes maximum time to complete one revolution? Neptune. Why? It is very far from the Sun. You got this point? Write down last point, 7th point. Under inner planets, write down inner planets. Write down. Inner planet takes as inner planets are close to Sun, as inner planets are close to Sun, they takes lesser time to complete one revolution. They take lesser time to complete one revolution. They takes lesser time to complete one revolution. They takes lesser time to complete one revolution. Full stop. Example: Mercury 88 days. Venus 225 days. Venus 225 days. Earth 365 days. And Mercury 687 days. These are the inner planets. Right, this is the asteroid belt, and outside the asteroid belt we are having outer planets. Right on the below outer planets, that side below outer planets. As these are located away from Sun, they takes more time to complete one revolution. As they are located away from Sun, they takes more time to complete one revolution. As they are away from Sun, they takes more time to complete one revolution. Example: so Jupiter takes 11.9 years, almost 11 years 9 months. And Saturn takes 29.5 years, 5 months, 29 years. And Uranus takes 84 years to complete one revolution. And Neptune takes almost 165 years to complete one revolution. Okay, the very important, very interesting fact here, please remember. So Venus is the only planet in our solar system that takes more time for rotation and lesser time for revolution. It is the only planet in our solar system that takes more time for rotation, lesser time for revolution, and remaining all the planets takes more time for revolution and less time for rotation, because Venus rotates in opposite direction and its speed is very less. Its speed is very less. Which speed? Rotation speed is very less, and that's why. So rotational speed is very less, and that's why it takes more time to complete one rotation. But the revolution time is more. Revolution speed is more. As the revolution speed is more, it takes lesser time. Very important point. Just try to note. So just try to next paragraph. Just the definitions are completed. Just next paragraph. Write down. note, under note write down. Venus is the only planet, Venus is the only planet that takes, Venus is the only planet that takes more time, Venus is the only planet that takes more time to complete one rotation. Venus is the only planet that takes more time to complete one rotation, but lesser time to complete one revolution, because its rotational speed is very low, Put double star, very important point. And many students will mark Venus will take more revolution time. That's a wrong statement, right? So because its rotational speed is very low, right? Full stop. So if you get the question, which is the only planet that takes more time for rotation and less time for revolution, answer is Venus. And remaining all the planets that takes lesser time for, you can compare any planet, including Earth or Mercury or Venus or Jupiter, any planet. So just listen here, Jupiter takes less time for rotation, less time for rotation, but more time for revolution, 11 years. Earth also only 24 hours for rotation, but 365 days for the revolution. Neptune just 16 hours for the rotation, but 165 years for the revolution. So when Neptune completes one revolution, in that time, so your 2 to 3 generation will complete, right? So that by that time, so your it will complete. So when you complete, because when the Neptune will complete one revolution, right? So because almost 2 to 3 generation of the people, right? That is very, very important point. So this is about the differences of planets, and this question came many times, please remember. And with this we have completed the planet topic, also very important topic, planets, right? And the important missions launched to planets, so that you will study, in your science and technology, which missions are launched, like Gaganyaan, Mangalyaan, Chandrayaan, all the missions you will study in your science and technology, right? So but I have given the base here, what is the planet and where they are located, which are the inner planets, which are the outer planets, which are more denser planets, which are less denser planets, which planet rotates faster, which planet rotates slower, that discussion concept we have discussed here. And some important facts for your prelims, right? So just write down some important facts for prelims, important facts for the prelims. So important facts for prelims, right? Important facts. Write down fact number 1, important fact. The smallest planet of our solar system is Mercury, right? Mercury is the smallest. Mercury is the smallest planet in our solar system. So Mercury is the smallest planet in our solar system, and it is closest planet to sun. It is closest planet to sun. Smallest planet to the smallest planet of solar system and closest planet to sun. It doesn't have any natural satellites. It doesn't have any natural satellites. It doesn't have a natural satellite. Very important point. It doesn't have any natural satellites because it is very close to sun. It is very close to sun. Listen, it's very close to sun. And if there is any natural satellites around to the Mercury, that will be attracted by the sun, because sun having more gravity, 274 meter per second square. So here, as Mercury is very close to the sun, it doesn't have any natural satellites. Very important point. If you get the question, so why Mercury doesn't have any natural satellite? So answer is, it is very close to the sun, and sun having huge gravity, and if any natural satellites revolves around the Mercury, that will be attracted by the sun. That's why it doesn't have any natural satellite. And please remember, so temperature on the surface of Mercury is almost 400 degrees Celsius, and that's why life is not possible on the surface of Mercury. Just write down. So it's Mercury surface consists temperature around 400 degrees Celsius. 400 par, आपकी बार 400 par current. This one temperature right? So your temperature, the Mercury surface consists temperature around 400 degrees Celsius. Therefore, life is not possible on the surface of Mercury. So because at 100 degrees Celsius water starts boiling, at 400 degrees Celsius you will become kebab, right? And that's why here life is not possible at 400 degrees Celsius. Very important point. So your temperature is 400 degrees Celsius, that's why life is not possible on the surface of Mercury. That is point, first fact. Now second one, second point, point number 2 about Venus. Venus, right? Okay, it is second closest planet, second closest planet to Sun, second closest planet to Sun, second closest planet to Sun, right? It is a twin planet of Earth, twin planet of Earth, twin planet of Earth. Third one, its surface temperature will be 461 degrees Celsius. And many students, if you get the question, which of the following is the hottest planet of our solar system, many students will mark Mercury by thinking that Mercury is very close to the Sun, it should be hottest karke. But the hottest planet of our solar system is Venus, not the Mercury. Why it is more hottest? So because it consists maximum carbon dioxide gas, and carbon dioxide gas is the greenhouse gas that traps, that absorbs the outgoing radiation, right? So here please remember, so your Earth atmosphere, listen carefully, if you take the Earth's atmosphere, right? So this is the Earth surface, and this is the Earth atmosphere, tropo, strato, meso, iono, exo, right? Troposphere, stratosphere, meso, iono, and exo. And our atmosphere, maximum, the largely available gas is nitrogen. 78% of the nitrogen will be found in our atmosphere. Second one is oxygen, 21%, right? And the minimum available gas is carbon dioxide. Just listen, carbon dioxide, CO2, 0.038%. And because of the CO2, with increase in CO2, the global warming is taking place on the Earth's surface. Global warming, because the CO2 will trap, it will absorb the radiation, right? Only 0.038% of the CO2 is there in our atmosphere, but still we are talking about global warming, climate change, that thing, this thing. But here Venus atmosphere, listen, Venus atmosphere, it consists 96% of the CO2. Just imagine, 96% of the CO2 is there in the atmosphere of the Venus, and Earth atmosphere having just 0.038, and in just 0.038 we are saying global warming karke. But there 96% of the CO2 is there, and that's why it is the hottest planet in our solar system. Right, in this one point, Venus is the hottest planet in our solar system. Venus is the hottest. Very important point. Put double star here and write down important. Very important. Hottest planet in our solar system. Venus is the hottest planet in our solar system. Due to presence of 96%, of carbon dioxide, in its atmosphere, due to presence of 96% of carbon dioxide in its atmosphere, right? This is about Venus. And one more important point, so Venus is also known as a brightest planet in our solar system. So it's the brightest planet in our solar system. Right, at this point, it's the brightest planet in our solar system. Venus is the brightest planet in our solar system. Due to two reasons. First one is maximum albedo. Due to maximum albedo of Venus. Second one, due to presence of H2SO4 sulfuric acid, due to presence of sulfuric acid particles in the clouds of Venus, due to presence of H2SO4 sulfuric acid particles in the clouds of Venus. 2 points are most important. This question already asked in the UPSC prelims exam. So why Venus is brightest? Because of these two reasons. One is because of maximum albedo of Venus. What is the meaning of albedo? Albedo meaning amount of reflection of the light. Just listen first. So here albedo meaning, suppose it is the Earth surface, it's a Earth, and this is the Venus. So when the sunlight falls on the surfaces, so how much light reflects back? That we call albedo, right? This is the sun, right? So this is the sunlight. So how much light is reflecting back? That we call the albedo. And Venus having 70% of the albedo means whatever light comes to the Venus, around 70% will be reflected back, and that's why it will shine. It looks bright. And Earth albedo is very less than 50%. Less than 50% is the albedo of the Earth, and Venus having maximum albedo, right? And it having sulfuric particles in the atmosphere of the Venus. And when this sunlight falls on that sulfuric particle, that particle will shine like Mercury, right? Sorry, Mercury. This one, radium. So in the roads, you might have see the radium in the night time, right? So they will shine, right? So similarly, so here also, so the sulfuric particles will shine in the daytime when the light will fall, and that's why we call very bright planet. So here Venus is very brightest planet of our solar system because of two reasons. One is due to maximum albedo of Venus, and second one is presence of H2SO4 sulfuric acid particles in the clouds of the Venus. This is very important point about the Venus. And Venus is also known as a morning and evening star. Just listen, morning and evening star. It is not the star. Please remember, it is not the star. So it is the planet. But we call star because it appears bright. Why it appears bright? So because of these two factors. It appears very bright. So because maximum albedo, and one is because of presence of sulfuric acid particles. As it appears bright, it appears in the night time also, it appears in the daytime also, and that's why you call morning star and evening star. So it is not the star, but appears is bright. In our solar system, we are having three bright objects. One is sun, moon, and Venus. And among these three bright objects, sun we call luminous object because it emits the light. But Venus will not emit the light. It appears bright because of the sun. And moon also appears bright because of the surface material and because of the even the sun. So they are not luminous objects, these are non-luminous, but they appears bright, and that's why they are known as star. But in practical, they are not the star. Write one more line, Venus. As Venus appears very bright, it is known as a morning and evening star. As Venus appears very bright, it is known as a morning and evening star, right? So this is about the Venus. And Venus also doesn't have any natural satellite. Why? What is the reason? It is very close to the sun, and sun having huge gravity, it doesn't have any natural satellite, right? So that's just very important point. Venus doesn't have any natural satellite. Doesn't have any natural satellites. Okay, and the life is also not possible because temperature is 461 degrees Celsius. Life is not possible. Next one is third one, Earth. Write down. As 71% inside the bracket 361 million square kilometers. As 361, so here 71% inside the bracket 361 million square kilometers. Area of Earth 71% or inside the bracket 361 million square kilometers. Bracket complete. Area of the Earth is covered by water. 71% or 361 million square kilometers of area of the earth covered by water. Therefore, it is known as a blue planet. Therefore, it is known as a blue planet. Therefore, it is known as a blue planet. Therefore, it is known as a blue planet, right? Full stop. It is the only habitable. It is the only habitable planet in our solar system till date. It is the only habitable. Habitable meaning which is suitable for life. Suitable for life, we call the habitable. It is the only habitable planet it is the only suitable for existence of life. So it is the only habitable planet in our solar system. Habitable meaning suitable for existence of life, we call the habitable. And as of now or till date, it is the only habitable planet in our solar system, and it is the fifth largest planet in our solar system. It is the fifth largest planet in the solar system after Jupiter, Saturn, Uranus and Neptune, right? After Jupiter, Saturn, Uranus and Neptune. So after these four planets, the fifth largest is Earth. Earth is the fifth largest planet in our solar system after Jupiter, Saturn, Uranus and Neptune, or after outer planets. All the four outer planets are large one, and Earth is the fifth largest planet, right? This is the fifth largest planet in our solar system, right? Next point. It is most dense planet or densest planet in our solar system. It's the densest planet in our solar system. It's the densest planet in our solar system, and density is 5.51 gram per centimeter cube. It's the densest planet in our solar system. It's the densest planet in our solar system, right? So it's very important point about the Earth, and it having one natural satellite. It having one natural satellite. It having one natural satellite, that is Moon. It having one natural satellite, that is Moon. It having one natural satellite, that is Moon, right? Okay, listen. And there are different theories related to formation of Moon, but one theory which is most accepted is, or the evidence which is most accepted is, listen, here Earth and Mars. Here Earth and Mars. So most of the evidence says that the Earth and Mars, they collided each other, and due to their collision, a piece of the material was removed from the Earth. The piece of the material was removed from the Earth, and that removed material. So after condensation, it became the Moon, and today it revolving around the Earth. So that is the evidence we are having till date. So here Earth and Mars, they collided each other. Due to their collision, the mass was removed from the outer part of the Earth, and that removed mass, it was very hot material, and after condensation, after cooling, it became a particular object or a particular celestial body, and it was named as a moon, and now it revolving around the Earth, and it takes almost 27 days to complete one revolution. It completes one revolution, and moon is the only natural satellite of our Earth, right? Just add to this point, right? As per many evidences, moon was formed. As per many evidences, moon was formed. As per many evidences, moon was formed due to material removed from the Earth's surface. 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 When Mars collided with Earth, right? When Mars Mars planet collided with Earth, when Mars planet collided with Earth, right? Full stop. Next point. Moon takes almost 27 days. Moon almost takes 27 days to complete one revolution. Moon almost takes 27 days to complete one revolution. 27 days to complete one revolution around Earth. One revolution around Earth. Moon takes almost 27 days to complete one revolution. One revolution around Earth. Right? Full stop. Okay, listen. And during the revolution of the moon, so it forms the different conditions or phenomena like solar eclipse, lunar eclipse, right? And even you will find the summer solstice, winter solstice. But your very important topic is eclipses. What do you mean of eclipses? What is eclipses? Grahana we call, no? Eclipses. Listen, there are two types of eclipse: solar eclipse and lunar eclipse, right? So here the sun, moon, and Earth. So their positions will cause the eclipses, right? Put the heading eclipses. Eclipses, right? Write down. Just write down one common line. Different positions of sun, moon and Earth. Different positions of sun, moon and Earth causes. Different positions of sun, moon and Earth causes two types of eclipses. Causes two types of eclipses. Eclipse meaning grahan, right? Eclipses, two types of eclipses. So one is on the left side, so solar eclipse, and the right side lunar eclipse, right? So your first one is solar eclipse and this side lunar eclipse. Solar eclipse and lunar eclipse. So here solar eclipse meaning, take this diagram below solar eclipse. Okay. So sun, moon and Earth. Sun, moon and Earth. So sun, moon and Earth, right? So here a sunlight falls on the surface of moon. Sunlight falls on the surface of moon. And here moon shadow falls on the surface of Earth, and it forms the dark region, and that dark region is known as umbra. And surrounding area, it's a light dark region, and that light dark region is known as penumbra. The light dark region is known as penumbra. So penumbra. So umbra and penumbra, right? So the dark region, umbra meaning more dark region. and penumbra meaning light or less dark. So this is about solar eclipse, right? Very important, solar eclipse or solar eclipse. And your lunar eclipse meaning right. So it is moon, sorry, sun, earth, and moon. Now here sunlight will fall on the surface of earth. And earth shadow falls on the surface of moon, and maximum portion of the moon will be covered by this shadow. That entire area we call umbra. And surrounding light dark region is known as penumbra, but larger area will be the umbra region. Umbra, penumbra. Umbra meaning more dark region. And penumbra meaning less dark region. Right, very important one. Umbra and penumbra, lunar eclipse, solar eclipse. And such diagrams will help you a lot in exam. Solar eclipse, lunar eclipse. Just if you read the theoretical part, you will forget, and with diagram you can remember easily. Or then okay, listen. Here solar eclipse and lunar eclipse. Solar eclipse, during solar eclipse, which object comes in the middle? So moon. Moon comes in the middle, right? And during lunar eclipse, which object comes in the middle? Earth. Earth comes in the middle. And during solar eclipse, whose shadow falls on whom? Moon shadow falls on the earth. And umbra will form on the surface of earth during solar eclipse. During lunar eclipse, umbra forms on the surface of moon, and there are such questions. And many students will think, well, they will study that during lunar eclipse, earth comes in middle, and during solar eclipse, only moon comes middle, and they will, and the topic complete. But here, UPSC will ask the question in detail. So they can ask the question, during which eclipse umbra forms on the moon surface. During which eclipse umbra forms on the moon surface? Answer lunar eclipse. During lunar eclipse, umbra forms on the moon surface. And during solar eclipse, umbra forms on the earth surface. And during, listen carefully, during which eclipse larger umbra forms? Again answer is lunar eclipse, because earth size is larger. As the earth size is larger, maximum shadow will form on the moon. Just see, almost half of the moon is covered by the umbra. But here, a very small portion of the earth is covered by the umbra. So these are very, very important points. Just write down the few points, write down. Just write down below solar eclipse. Below solar eclipse, write down. Write down below solar eclipse. And whenever you draw the diagram, you should not forget to mention figure, right? You have to mention the figure name, lunar eclipse, and solar eclipse. So write down below solar eclipse. During solar eclipse, moon comes in between. Moon comes in between. The sun and earth. Moon comes in between the sun and earth. Full stop. During solar eclipse, in the same point, during solar eclipse, sunlight during solar eclipse, sunlight falls on the surface of moon. Sunlight falls on the surface of moon. And moon's shadow falls on the surface of earth. Moon's shadow falls on the surface of earth. And forms a dark region. Forms a dark region, which is known as umbra. Forms a dark region which is known as umbra. Right? Listen. So during solar eclipse, where sunlight falls on the surface of moon, and moon's shadow falls on the surface of earth, because moon doesn't have its own light. That's why moon shadow falls. Listen, when we stand here, our shadow will fall backside because we don't have our own light. So that will, our body will prevent the light, and that's why shadow will fall on the backside, right? So here shadow of the moon will fall on the earth, and that dark region we call the umbra, right? And surrounding light dark region or less dark region known as penumbra. And surrounding less dark region is known as penumbra. Surrounding less dark region is known as penumbra. Right? Penumbra. Okay, next under lunar eclipse, write down. Below lunar eclipse, write down. During this lunar eclipse, earth comes in between sun and moon. Earth comes between the sun and moon. Full stop. Here sunlight falls on the surface of earth. And earth's shadow falls on the surface of moon. Earth's shadow falls on the surface of moon. Earth's shadow falls on the surface of moon and forms a dark region. Which is known as umbra. And surrounding light dark or less dark region surrounding light or less dark region, surrounding light or less dark region is known as penumbra, is known as penumbra, is known as penumbra, right, is known as penumbra. Very important point, right. Shruti we saying that 80 days or 88 days or 88 years. Where in Mercury, right? So Mercury I have mentioned 88 days, right? Not year. It's a 88. कहाँ चला गया वो? Okay. So listen. So here 88 days. कहाँ है वो 88 days? It's 88 days only. I have mentioned days only. So Shruti say 88 days, not the years. 88 days, right? So 88 days. So your Venus also, it's a days only. Days only. It is 88 days, not the years. 88 days. So only the outer planet takes in the years, not in the days. But the inner planet they complete the revolution in the days only. So here only Mars takes maximum days to complete one revolution. 367, almost 687 days it will take. So otherwise, Mercury will take 88 days. 88 days. It's not the year, right? Shruti Sharma ji. Outer planets take more time for revolution. Okay, good. Meenakshi saying outer planet takes more time for revolution. That's correct, because outer planets are away from the sun. That takes more time. Correct. Okay, next point. Okay, so this is about the eclipses. So very important point. Outer this one, solar eclipse and lunar eclipse. And if you get the question, just listen. So when sun, moon and earth comes in a straight line, if suppose, so this is the sun, right? This is the sun and moon, and this is the earth, right? Earth. It is one condition. Another condition, sun and earth and moon, right? Just listen. So your sun, moon and earth, and your sun, earth and moon, right? Okay, listen. So all the three are in the straight line only. All the three are in straight line, right? All the three are in the straight line, right? So here also all the three are in the straight line, but positions are different. When they comes in a straight line, so that we call syzygy. Right? Just listen. So when they comes in a straight line, we call syzygy. And within syzygy, there are two types. One is syzygy. Listen carefully. So one is known as, so this is the figure of syzygy conjunction. And it is the figure of, or it's a type of syzygy opposition. So we call syzygy opposition. Because here sun and moon are in the opposite side of the earth, right? Please remember. So both are in the opposite side. That's why we call syzygy opposition. And here syzygy conjunction meaning on the same side. So your sun and moon are on the same side of the earth. That we call syzygy conjunction. And if sun and moon are on the opposite side of the earth, we call syzygy opposition. And syzygy opposition, it is also known as lunar eclipse condition. It is also known as lunar eclipse condition, right? So it is also the position of lunar eclipse. It is also the position of solar eclipse. Solar eclipse. But the most important point here is syzygy conjunction, syzygy opposition. If all the three comes in a straight line, we call syzygy. And if sun and moon comes in the same side of earth, we call syzygy conjunction. If sun and moon comes in the opposite side of earth, we call syzygy opposition, right? Just on this point, put the heading syzygy. 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 Write down. If all the if sun, moon and earth, if sun, moon and earth, if sun, moon and earth, if sun, moon and earth comes in a straight line, comes in a straight line, comes in a straight line, then it is known as syzygy. It is known as syzygy. If sun, moon and earth comes in a straight line, then it is known as syzygy. Syzygy. Syzygy, right? Full stop. There are two types. There are two types. There are two types. First one, syzygy conjunction. Write down just on the left side syzygy conjunction, right side syzygy opposition. Take this diagram. Syzygy conjunction and syzygy opposition. On the left side syzygy conjunction, on the right side syzygy opposition. And take the diagrams. So syzygy conjunction. First left side diagram, on the right side syzygy opposition. And syzygy conjunction meaning sun and moon both exists on the same side of earth, on the same side of earth. Sun and moon both exist on the same side of earth. And here syzygy opposition meaning sun and moon both exists on the opposite side of earth, opposite side of the earth. Opposite side of the earth. Sun and moon both exist on the opposite side of the earth, and here on both the sides. This is very important point. On the same side, here same side, and here opposite side. These small terms will make the statement confuse, right? So here on the same side and on the opposite side, or on the same side and opposite side. Then, so this is about the syzygy and even about the moon, right? So now put the heading types of one more important point. Just listen. Is for okay, listen. So when a sun or when moon is revolving, just listen. This is the earth, right? Earth. So when moon is revolving, around the earth, so sometime it comes very close to the earth, and sometime it goes very far from the earth, so because their orbit is like that only, so sometimes it comes very close to the earth, and sometime it goes very far from the earth, right? Okay, listen. So here when the moon revolves around the earth, so it sometimes comes very close to the earth, and sometimes it goes very far from the earth. So when it comes very close to the earth, so that we call perigee. Perigee meaning, so when sun comes very close to the earth, and when moon comes very close to earth, and when moon comes very far, or when the moon goes very far from the earth, right? So it is very far position. It is known as apogee position. Apogee meaning when moon goes very far from the earth, and almost it goes 4 lakh 5,800 kilometers, right? And during perigee position around 3 lakh 65,000 kilometers, right? And if you take the average distance of earth and moon, please remember the average distance between earth and moon. Average distance between earth and moon will be 3 lakh 84,400 kilometers. And this distance is very important because Chandrayaan 3 became successful, and they can ask direct question on this distance. The average distance between the earth and moon is 3 lakh 84,400, right? But the maximum distance between the earth and moon is around 4 lakh 5,000, and the minimum distance will be around 3 lakh 65,000. That smallest distance we call perigee, the longest distance we call the apogee. Got this point, right? So if right, let's start on one line. So during revolution, moon comes very close to earth. During revolution, moon comes very close to earth, is known as perigee. During revolution, moon comes very close to earth, is known as perigee. And when it goes very far, is known as, it is known as apogee. When it goes very far, it is known as apogee. Don't write apache, mamaji, kakaji, right? Apogee. When it goes very far, it is known as apogee, right? When it comes very close, we call perigee. When it goes very far, we call apogee, right? So this diagram you have to take, right? So this is about the sun, moon, earth, and even all the inner planets, right? So we'll take a break now, and lunch break, and we'll start at 2 o'clock. In the 2 o'clock class, that from 2 to 4 p.m. class, we'll discuss about remaining 4 planets, and you will discuss the types of the moon. We are having different types of the moon: new moon, full moon, blue moon, red moon. There are different types of moon, so that we'll discuss after the lunch break. Types of moon and even another 4 outer planets. Time? What time? So for sun we can say the date, because it's very difficult to say the dates for the moon. So because when we'll talk about the earth and sun, just listen. Here sun, and this is the earth, right? So here earth sometime it goes very far from the sun, and sometimes it comes very close to the sun. And when it comes very close, just listen. This is the earth. This is also the earth. When earth comes very close, that we call perihelion position. And when the earth goes very far, we call aphelion position. And during aphelion position, the distance will be 152 million kilometers. And during perihelion position, the distance will be 148 million kilometers. And the average distance between sun and earth, so it will be 150 million kilometers, and it comes very close on 3rd January every year, and it goes very far every year on 4th 4th July. That date you can say because it's a yearly revolution, but it rotates in 1 month. Then how come you tell the dates? Because date will change, right, every month. So because 1 month consists 29 days, 1 month consists 31 days, 1 month consists 30 days, it's very difficult to say the dates. But here we can say because it's a yearly revolution, Earth takes 1 year to complete the revolution. And during perihelion position, perihelion meaning when Earth comes very close to the Sun, we call perihelion. And perihelion occurs on 3rd January generally. Not exactly on 3rd January, sometimes it can be 2nd January also, sometimes it can be 4th January also, but generally it occurs on the 3rd January. And on 4th July, Earth goes very far from the Sun. And again, not exactly on 4th July, sometimes it can be 5th July also, sometimes it can be 3rd July also, but generally, so it occurs on the 4th July. But here, Moon takes just 27 days, and how come we will have to tell the dates? It's very difficult to tell the dates, right? Okay, so this is about the revolution of the Moon, and this is the revolution of the Earth. Revolution of the Earth. So revolution of the Earth, and if you get the question, what is perihelion and aphelion? Perihelion and aphelion are related to the Earth and Sun. Apogee and perigee are related to the Moon and Earth, right? So we'll take a break, lunch break, and then we'll start the class. Because the class next session will be from 2 p.m. right? Okay, thank you so much. Take care. Bye bye. Dhanyawad. So in 1 year, so here Devraj asking how many syzygy happens in a year, right? So syzygy, please remember syzygy when these 3 comes in a straight line, and these 3 can come in a straight line 6 times, minimum 6 times, because in 1 month, at least they come straight line, at least once they comes in a straight line. Just listen. So when we'll discuss, very good question he asked, how many syzygy occurs, right? Listen. So here Sun, Moon, and Earth, or listen, so here the Moon also can come here also, right? Moon. So here syzygy, so here Sun, Moon, Earth. So Sun, Moon, Earth, and Sun, Earth, and Moon. So here they comes in a straight line, and again after 15 days, or 14 days you can say, after 14 to 15 days, so again they comes in a straight line. And again after 14 to 15 days, again they comes in a straight line. So means in 1 month, at least they comes 2 times in a straight line, 2 months in a straight line. And if you take 12 months, 12 into 2, 24 times. So your answer is 24 times. How many times the syzygy forms in a year? Then answer is 24. In 1 month, how many times? 2 times. And because here Sun, Moon, Earth, because your Moon takes almost 27 days or 28 days if you consider, if you take 28 days, 14 days, so there 2 times comes in a straight line. So that's why syzygy occurs almost 24 times in a year, 2 times in a month. You got it, Devraj? Okay, dhanyawad. Okay, take a lunch break and come back.